In section 7, we're going to start taking a look at circles. So just kind of to review, a circle is a set of points equidistant from a point called the center. Okay. Circles are named after their center, so whatever that center point is labeled, that's what we call it. Circle A, circle O, circle L. All right, then we have our radius, which is the distance from the center to any point on the circle. We have our diameter, which is a line segment connecting 2 points on a circle that passes through the center. So there's a lot of different line segments you can construct in a circle that don't go through the center, and the diameter is specifically the one that goes through the center. To review, area is pi r squared, and circumference is 2 pi r, or pi times the diameter, depending on how you want to look at it. Because remember, the diameter is twice the radius. Another way to think of it is the radius is 1/2 of the diameter. Both of those are true statements. We're also going to talk about something called radians. So normally we talk about measures of angles or in circles, and we talk about degrees. So a radian is a unit of measure for angles based on the radius of a circle. So it's another method to represent angle measures in a circle without degrees. Okay, so there is a method for converting between degrees and radians and degrees. So if you remember, if you have some angle measure theta, which is what we use to denote angle measures, there are 360 degrees in an angle, but to convert to radians, we just multiply by pi over 180, which is half a circle. Right? If you're going the reverse, you have something in radians, which we abbreviate RAD. You multiply by 180 over pi. So it's just the reverse. Okay. Let's look at a few examples. So we have 25 degrees, and we want to convert that to radians. So I'm going to take my 25 degrees, and I'm going to multiply it by pi over 180. Now, when we're converting between radians and degrees, we don't get rid of the pi. Our answer is actually going to be left in terms of pi. What we do is we simplify the degree measure in the 180. So this is 25 over 1. So I need to figure out, all right, what goes into 25 and 180. So I'm always going to check the number itself, 180 divided by 25, not a whole number. The only other number 25 is divisible by is 5. So 25 divided by 5 is 5. 180 divided by 5 is 36. And I'm going to leave my answer as a fraction in terms of pi. So I'm going to have 5 pi over 36 radians. We're going the other way. So I have 2 radians. I want to know what that is in degrees. So a lot of the time when we're converting from radians to degrees, pi will be part of our answer. But in this case, it's not. So I'm going to have 2 radians times 180 over pi. So typically speaking, my answer would have pi in it, and the first thing that I would get rid of is pi. But in this case, there isn't, so my answer is going to be in terms of decimals. So I'm going to do 2 times 180, which is 360, and then I'm going to divide by pi. And I'm going to get 114.6 degrees. Okay. It is important that we indicate our units here. So for radians, the unit is just RAD for radians, and for degrees, you put degrees. Okay. Next, we have 175 degrees. So we're going to have 175 times pi over 180. So I'm trying to figure out what goes into 175 and 180. I know it's not going to be 175. I know 180 isn't divisible by 25. So we'll just do 5 again. So 175 divided by 5 is 35. We already know that 180 divided by 5 is 36. So we're going to get 35 pi over 36 radians. Okay. Last example of 3.5 radians. So we're going to have 3.5 times 180 over pi. So we're going to do 3.5 times 180, and then we're going to divide by pi. And we're going to get 200.5 degrees. Next thing we're going to talk about are the central angle and arcs of a circle. So when we're looking at a central angle, it is the angle at the center of a circle with endpoints on the circumference. So I'm going to draw a circle. So you have a circle, and we're going to label our center A. I can draw any two radii, which is the plural of radius, label them with points B and C. Now, we're going to talk about arcs here in a second. But depending on what I'm looking at, my central angle, and which the center has to be the second letter, my central angle is angle BAC. I could also technically name it CAB. That also works, but A has to be the second letter since that's the center of the circle. Okay. Arcs are a section of a circle, specifically on the outside. So in the circle I just did, BC here is an arc because it's part of the circumference of my circle. So they are named using points on the circle. Okay. Now, there are such things as major arcs and minor arcs depending on what you're looking at. Because in that circle, how do I know if I'm looking at BC between them or BC around the outside? So the way we distinguish between the minor and the major arcs is depending on the number of letters we use to name it. So a major arc is an arc measuring more than 180 degrees, and we use 3 points to name. So if I added an additional point on this circle, my major arc, which we use a little arc, would be BDC. Okay. Minor arc are arcs measuring less than 180 degrees, and we use 2 points to name them. So my arc BC is my minor arc. So looking at our example, we want to name 2 minor and 2 major arcs of our given circle. I don't have to have my radii or my radius drawn to each of those points because arcs are looking at the outside of the circle. So let's start with our 2 minor arcs. Okay. So for example, arc MP is minor. I know that's less than half the circle. So you don't have to know exactly what it measures because 180 degrees is half the circle. So as long as your arc takes up less than half the circle, you're good. And then I could also use RQ. So even though it goes through point L, I don't have to use that as part of my minor arc. Okay. Next, let's look at a couple major arcs. So remember, I have to use, it has to go more than half the circle, and I have to use at least 3 letters. So if I want to go from M all the way to N using a major arc, I start at M, I end at N. Now, it does go through 3 different points between then, R, L, and Q. And I can use any of those letters in naming my major arc. It just has to be one of the points it goes through. My other option is the major arc that belongs to, well, not my only other option. One of my other options is the major arc that belongs to MP or RQ. Or I can come up with another one. So let's look at going from N to Q along a major arc. So I'm starting at N, I'm ending at Q, but I want to do a major arc, so as long as I have one letter in between, like N. So NLQ, I know, goes the long way around the circle, not directly to Q. Let me know if you have any questions about circles, converting between degrees and radians, central angles, or arcs.